Hello. How is everyone? I'm sorry. It looks like I'm quite late, 8 minutes late. Got wrapped up in the meeting from this morning and then trying to get ready for this right now. So I apologize. Looks like there isn't anyone here. Okay, there are a few people here. Let me move the light so that we can have some video happening here. And this is what we had covered the last time. Is that right? Yeah, that looks fairly good. So this is what's happening this week. Food for thought. Um, I think that was pretty self-explanatory. A few quick videos and a PowerPoint, I believe, or maybe not. And then some questions. Calculate your carbon footprint. So I realized yesterday that was down. It was not working. So just try to get it done before the break. Um, and if you don't get it done before the break, do it after the break. But it may help you when you're taking the quiz tomorrow. Study guide that's due today, so we'll finish that up today. We did 1 through 8. On Monday, we'll go through 9 through 16 today. And then tomorrow is a quiz. So I do need to say that the quiz is going to be available to you from 8 a.m. to 3:10 p.m. tomorrow. You need to do it in that time. If you don't get it done in that time, I'll have to make up another quiz. And you know what that's like. I have to do more work, so so do you. Looks like I still have my robe on. I apologize. Um, how many questions are on the study guide? 16. I believe the test is 10. Good morning. Yes, it is Wednesday, my dudes. So let me think. I have some things for you to do over the break if you want. You may have seen those in there. There's an extra credit on marine debris, and I find that really important to know about, just to know about. So there's a video in there to watch about the Pacific garbage patch. So it's important to know that that's happening. Um, And then there is trash on the spin cycle. Oh, so I have that confused. Trash on the spin cycle is specifically about the plastic that's floating around. There are actually 5 different gyres in our oceans, um, where the currents move in such a way that the trash collects there. And plastic is a great deal of what collects there because it doesn't go away. Food and anything that's organic is going to break down and become part of the cycle of life. Um, but plastic is manufactured, it's man-made, so it doesn't go away. So that's what that assignment is about. There are 2 different ones on there. And then the other thing, if you don't like your grade for third quarter, and I must indicate that third quarter is going to be the majority of your grade for the semester. If you don't like your grade for third quarter, there are some things that you can still do about it. So I haven't said anything about the performance task, um, but that's also a possibility. And the other thing is that greenhouse effect, that's something that I graded the last week of um, of the semester. So you might not have realized that you hadn't turned that in. And there's another assignment. I don't remember the name of that one, but that was also that was a web quest. So that was climate change web quest. And I also graded that the last week of the quarter, even though you had done it sooner. But I didn't feel that you had the opportunity to make that up, not knowing that you hadn't gotten it turned in. So it's not for full credit. Um, that was before any of this happened, but you can make that up and help improve your grade. And that's important because the majority of your grade will be based on what happened in third quarter. So let's go ahead and take out that study guide. We'll start with number 9. Describe renewable and non-renewable energy sources. So renewables come from sources that can be replaced in a reasonable amount of time. Maybe we're talking about one growing season, and there might be 3 or 4 growing seasons in a year on some of these things. Maybe we're talking about within a few years that the energy source can be replaced or replenished. If we're talking about wind and solar, you have more solar in the summer than you do in the winter. You have more solar during the day than you do at nights, but there's basically a 24-hour cycle on that, depending where you are geographically. And then wind and tide. Tide comes in and out twice a day. Wind, there are certain places that are windier than others due to the geography, but there are certain times of the day, in the morning and the evening, because of the unequal heating of the earth, that if you're close to water, there's a difference in temperature between the air that's over the water and the air that's over land. So there's wind in the morning and the evening. So it might not always be there, but it can be replenished. Now let's talk about non-renewable energy sources. Come from sources that will run out or will not be replenished in a reasonable amount of time. So we're talking about fossil fuels that took millions of years to form. Those are all non-renewable. So for renewable, number 10, renewable, we have geothermal. And you may not have heard much about geothermal, but that's when the heat from the earth is used to turn a turbine so that heat rises. So you have dug into the earth where there's a geothermal source, that heat rises and turns a turbine. The turning of that turbine stores energy, and that produces electricity. That turbine, you either have a conductor. We'll go into electricity later, so you don't have to know the specifics of any of this, but you have the conductors moving past magnets, and that creates an electric current in the conductor. And a lot of these renewables have to do with the same type of thing. You have a turbine that's like a fan blade. We have wind. We already mentioned wind power, hydro. So that's anything to do with water. It could be tidal. It could be rivers. It could be from a dam. So like the Hoover Dam, we get a lot of electricity from the Hoover Dam. I'm not sure where that specifically goes. I don't think we get much from that anymore. I think it's mostly further east that's allotted to, but that's an example that as the water goes from a higher level, higher potential energy to lower potential energy, it's releasing its energy. And again, that can be used to turn a turbine that produces electricity. Um, Solar, we know about solar. A lot of houses have solar panels on them. We in the parking lot over at PHS, we have solar panels um, above the parking. It's not really, it's parking spaces, and there's the roof, and the roof has the solar panels. So we get the idea of solar. There are a lot of houses that have solar also. Biomass, that's anything that was once living can be burned. And again, I've mentioned this more than once, but we're still putting CO2 into the air. The advantage is that that material can be replaced in a reasonable amount of time. When we're burning things like the dead crops that a farmer um, does a burn at the end of the season so that the land is cleared for the next time, um, we're using that. uh, if we go ahead and collect those dead crops instead of just burning them where they are, then we're using that resource for energy that we're still putting the CO2 into the air, but those crops, the carbon is going to be recycled into the environment one way or another. Um, so that's the advantage. It can also be replaced with the next season. That carbon can be replaced within the next season. Um, Now, number 11, we have list five non renewables. So that's our fossil fuels, um, coal, oil, natural gas. That all comes from the same place. No, coal doesn't come from the same place that we get oil and natural gas from. Oil and natural gas come from the same place. So when we find oil somewhere, there's a pocket of natural gas that is above that. Um, the propane is manufactured from that natural gas. And then we also have non-renewable, we have nuclear listed. Nuclear can also be considered renewable because we can we can replace the source of energy, but many organizations consider nuclear non-renewable. Um, and it also depends on how the nuclear is being produced. There are newer technologies that do not have radioactive waste when they're collecting the nuclear energy. The only waste is hot water. Um, that doesn't mean that it doesn't have to be dealt with appropriately. It does, because if you release that hot water into the environment, now you're changing the ecosystem of that water. So that has to be something that's considered. Describe number 12, describe positive and negative feedback loops. So Daisy World went into that a little bit, and there's a PowerPoint. I actually just posted that in your materials on Wednesday. Um, no, yesterday. I posted that in your climate change materials. So that might be a real quick um, thing to take a look at so that you're refreshing the idea of the feedback loops, or maybe you have your notes from before the time that we've been away from school. Um, and you might want to take a look at those. So, a positive feedback loop begins with a change in the system that leads to another change that is either increasing or decreasing. When we talk about climate change, we're talking about the temperature increasing. But a positive loop does not always have to be something is increasing. It could also be decreasing. Um, that leads to a different state than the original. So after we release carbon dioxide into the atmosphere, the temperature increases, and that leads to a higher global temperature. So we're not at the same temperature that we were before. We have global warming. All right, so that's positive. Um, it means that the system is unstable. It's not going back to equilibrium. It's not going back to a stable state. The system is unstable. So, a negative feedback loop, usually we think about negative as a bad thing, but um, usually we want stasis, we want equilibrium. If you're building a bridge, you want the bridge to stay there. So you want all the forces to be in equilibrium. Same thing with a building of any sort, any type of structure. You want equilibrium so that it's stable. So a negative feedback loop begins with a change in the system that leads to another change, either increasing or decreasing, that leads to the same original state. Um, that's that's a stable system. That's stasis or equilibrium. And that's what we want. That's what we want with climate change, unless we can get it to start decreasing in temperature. But that's going to take a long time to do that because we know that carbon dioxide stays in the atmosphere for a really long period of time. We can get rid of the methane a lot quicker, and methane is very destructive, than we can the carbon dioxide or the water vapor. And water vapor is very destructive to the atmosphere as well. So now I need to diagram two positive feedback loops. And unfortunately, I erased the one that I had done on Monday on ice albedo, so I'll have to try that again. But here's another one. Ripening of fruit. So we start, let me get my markers. With our fruit ripening. And that leads to the fruit. I should do this smaller. I can erase that one. That leads to the fruit giving off ethylene. Uh, and if you want to know what that is, that's C2H4. So that's similar to methane, but not quite. So it makes a difference. Now, when other fruit is exposed to that CH4, I'm sorry, C2H4, that leads to other fruit that ripens. And then more fruit give off the ethylene. and that leads to fruit ripening. So, in fact, it seems like it's a little bit contagious, isn't it? Once the first fruit on a tree ripens, then the rest of them are going to ripen in a similar time frame. So this is again a positive feedback loop. We're not going back to equilibrium. We're getting more and more fruit that are ripening throughout the process. But that's what we want, right? We want the fruit to ripen. Isalbedo. I'll just do a really simple one here. So we'll start with ice melting. That leads to lower albedo. So less light or less energy is reflected back out of the atmosphere. That leads to warmer temperatures. That warmer temperature leads to, we talked about the oceans and land. So this warms Earth's surface. And that leads to more ice melting. So we have less ice. Once it starts melting, we have less ice than we started with. So again, this is a positive feedback loop. So this is a positive feedback loop. Ice melts, lowers the amount of energy that's being reflected. Temperature rises. That temperature rise warms the Earth's surface. That's land and water. We get more clouds. We get more greenhouse gases from that because you get more water vapor in the air. And then that leads to more ice melting. So that was two positive feedback loops. And now these are the same two negative feedback loops that we've been using. There are a lot of others, but I kind of stuck to these two. They're simple. I think they give the idea. You're cold. So something happens to warm the person. Maybe the environment, maybe it's hot outside, or maybe you're exercising. Your body becomes too warm, and then you sweat, so you cool off. So you're coming back to equilibrium. We're not reptiles. We need to have the same body temperature around 90, what is it, 96.8. You need to be around 96.8. So your body has mechanisms to maintain this correct body temperature. So if you're cooler, the person warms either from the environment or from exercise or maybe some other thing. You become too warm, you sweat. The other one is, what if you're too hot? Your body cools. Maybe it's cold outside, you are inside, your body is warmer. So perhaps we're starting at the right temperature. You go outside where there's snow and ice, and you become too cold. So you shiver to bring your body temperature back to stasis, back to equilibrium. So these are examples of negative feedback loops. Okay, so let me go ahead and take a look at your questions before we go on. We have a few more questions on the list. We can't do the quiz today, no. The quiz will be available tomorrow morning at 8 a.m. and you need to do it between 8 a.m. and 3:10. What wouldn't allow you to open an assignment yesterday, Adrian? I'm not sure what assignment you're talking about. If you're talking about the quiz, then that's because it's not open yet. I didn't think you could see it yet. Is uranium a non-renewable? And again, that depends on who you're talking to, if that's a non-renewable. But for the sake of what we're doing now, we can consider it non-renewable. I actually believe in nuclear energy as a good way of getting our energy. It has to be done correctly, but it's a very clean energy. It's an extremely clean energy. We're not doing anything bad to the ozone, to the atmosphere when we're using nuclear energy. But we don't have time to really go into what exactly is this nuclear energy. Can we use those diagrams? Yes, you can. The carbon footprint. Okay, the carbon footprint was not working yesterday. I went in this morning and it is working this morning. I didn't really want to try to find a different footprint calculator because then I would have had to change the instructions because you would have different questions that you would be able to answer depending on a different calculator. But it's working today, so do your best to try to get to it today or tomorrow. And again, there's no point deduction for things being late, especially since you couldn't even access it yesterday. The carbon footprint. The quiz is already posted. It shouldn't be open. So Darren, have you been able to open it? Has anybody been able to open the quiz? You were not supposed to even, I didn't think you could see it. Nobody's going to answer me. All right, well, let's go ahead and continue with the study guide, and maybe by the end, somebody will get back to me letting me know about that quiz. You're not supposed to be able to open it today. Diagram 2 negative feedback loops. So we're on number 15. How are ice cores valuable in combating climate change? So we went over ice cores when we did the inconvenient truth. You might want to be, so Darren, yes, you've been able to do the quiz. I'm gonna go look in classroom. Oh, I can't. Let's go to okay, so mine is saying that it's available tomorrow morning at 8 a.m. Yes, we can access it. So you're able to open it and take it? Because what it's showing in mine is that it's what period is that? Maybe I made a mistake on a different period. I can't even see it. Okay. Okay, that was period 1 that I looked at. Let me look at period 2. You're right. Period 2, I must have made a mistake. Okay, I'm going to have to delete this from period 2. And I'll go ahead and post that again later. Let me see the other periods if it's there. Period 3, it's scheduled for tomorrow. Period 5, it's scheduled for tomorrow. And period 6, it's scheduled for tomorrow. So evidently I made a mistake when I posted it for period 2, but I've removed that now. So I will have to, so Darren, do me a favor and delete that. You're not supposed to have access to that today. I can't see it. Yes. I'm a take it tomorrow. Okay. We're period 3. Okay, so period 3, it's scheduled for tomorrow, 8 a.m. All right. Let's go on to ice cores, number 15. So you can go back and look through your notes from Inconvenient Truth. I'll go over the juxtaposition of that right now. So there are two things that we really get from the ice cores. There's a lot of other information that we can get from the ice cores, and some of it goes back to the formation of the universe. But the two things that we're concerned about with climate change are the composition of the air. So there are air bubbles that are stuck in that ice, and that tells us exactly what the air was composed of at that time. And then, because of the isotope of oxygen that is there, we know the temperature. So, oxygen is different, has different isotopes depending on the temperature. We can very precisely measure the temperature at that time. So that's what the ice cores tell us. They tell us the composition of the atmosphere, and they tell us the temperature. The ice cores can be read similar to the rings on a tree. When you cut the tree and you have a slice of the tree, you can You can read things from those rings on the tree so that you gain information about the tree. And that's the same with the ice core. Um, this helps us because we know what has happened over hundreds of thousands of years of the history of the earth. We know how the earth cycled. So that helps us to determine what is going to happen next. It helps us to figure out what this amount of carbon dioxide and other greenhouse gases in the atmosphere, what does that mean to us? So that helps us figure out what do we have to do or what can we do to mitigate climate change? What can we do to help solve this problem of global warming? And then 16 lists 3 things that you can do to reduce global warming. So that is one of the questions on the assignment from yesterday. I know most of you weren't able to do it yesterday. I think a few people were able to get to it later in the day, thinking that it came back up later. But the last question on there was to research 9 ways that you can reduce steps that you can take. So anybody have something that they can give me? I'll wait for a minute. I'm not going to just go through my list. So it doesn't look like I'm getting feedback here. Plant trees, dry your clothes on the line. Okay, those are good ideas. So you're reducing your energy use. Plant trees, you're putting more oxygen into the atmosphere and taking carbon dioxide out. I need a few more. And some of these things you already know. We talked about some on Monday a little bit. Recycle, perfect. I like the 3 R's: reduce, reuse, and recycle. So, because processing recyclable materials so that you can use them again also produces greenhouse gases. It takes energy to do that. So that's a lot better than just buying everything brand new, but it's still not the big idea. The big idea is to reduce what you buy, reduce the things that you buy, reduce the energy that you use more efficient light bulbs, use more efficient appliances, use a car that uses that doesn't use fossil fuels. Put solar panels on your home so that you're using solar energy. But reduce, reuse. So don't throw things away. Every time you throw something away, it ends up in a landfill or in the ocean. And we don't want either of those happening. So reduce, reuse, recycle. We talked on Monday, maybe it was last week, I don't know, but I thought we talked on Monday about cows. Is beef the best choice for your diet if you're considering the environment? Eating different types of plant-based proteins. Yeah, that's definitely a good idea. You can beans, you can get your protein from beans, insects, tofu, nuts, seeds. Who here has tried insects for lunch? It's not the most appetizing idea, and I don't think that you would want to base your diet on insects all the time, but they actually sell chips that are made from insects instead of, I don't know what else you would use, but instead of flour and other grains. And they taste the same as any other chip. It depends on how it's flavored. But those are insects. It's made from insects. And there's this idea that as population is growing on the planet, we're not going to be able to provide food for everyone. We already have places where people are starving. Um, but as we grow, as the population continues to grow, resources are a problem. So if we can farm insects as food, then we can begin to address some of those issues. I tried a cricket. How was it, Darjari? Eat less dairy is another thing, and that's because, like we talked about, the cows produce methane. So the less cows that we are farming, raising for food and dairy, then the better the environment because of the methane that they release. But it's not only the methane that they release, it's the land use. We're cutting down trees so that we can have pastures for the cows. And it's also using the tractors that use fossil fuels to maintain those farms. It was weird but tasty. Since it lemon tasted like chicken, it had lemon. Okay, so it tasted like lemony chicken. Yeah, whatever they're seasoned with, those insect chips are. That's what they taste like. Um, Eat local food. I don't know if anyone has thought about that, but a lot of our food comes from other places. So that means that we've had to use fossil fuels to get it here. Maybe it's coming from Chile, maybe it's coming from the other side of the country. I know Ruskin, Florida is famous for their tomatoes. They send them everywhere around. You can't buy Ruskin tomatoes in Ruskin, Florida. But that transportation costs us not only in money, but also in the fossil fuels that are emitted, getting it to a different location. So when you eat local, go to the farmers markets, go to farm stands, get your food locally grown, then you're being part of the solution instead of part of the problem. Eat seasonal food. So that's another reason that we transport foods so that we can have strawberries in the winter. They grow in the summer, right? But other places have summer in our winter because they're south of the equator. They grow strawberries then, and then they send them they transport them to us so that we have them in our grocery store. Use use energy efficient bulbs and appliances. We already talked about that when we said reduce what you use. Walk or ride a bike instead of using a car. So those are the things that I had for that. Are there any other questions before we move on? For the break, there's no homework, but like I had said, there's the extra credit assignment, and then also in order to improve your grade to ensure that you are passing for the semester, then you have to do something about that third quarter grade if it isn't what you want it to be. So there are assignments posted in Google Classroom so that you can do that. All right. Any other questions? Well, have a good one. Enjoy your spring break. Stay safe and stay healthy. We are not having the live on Friday. Whose birthday is it? Whose birthday, Darjeri? Is yours on Friday? Oh, it's on Saturday. Well, can we sing happy birthday right now? Happy birthday to you. Oh dear. I'm the only one singing. Happy birthday to you. Happy birthday, dear Darjeri. Happy birthday to you. Yay! All right. So have a good break. Relax, stay healthy. And if you have things to get caught up on, if you haven't finished up that final draft, I've graded first, second, and third. So I may have sent it back to you with ideas on how to fix it to get a better grade. Please do that. So I am asking that you monitor what's happening with your grades in classroom, because I'm putting in a lot of time and effort into giving you ideas on what the assignment should look like. And a few people are responding and they make those corrections and resubmit. But mostly when I send it back, it's getting sent back to me in the same condition that it was in. So after that happens the second or third time, I just give you a 0 for it. And I don't want that happening. So please take a look at the comments and the posts that I'm making. They should be showing up in your email. So please read those and do something about that. I know you're probably using an email address that you don't monitor, but I want you to do that so that you can do something about your grade, okay? So have a wonderful, mine was fine, right? I think so. I think so. I don't remember off the top of my head, Darren. I'd have to take a look. But enjoy your spring break. Bye bye.